Okay, in this problem, turns of a uniform spring of relaxed length L equal to 1 meter and force constant so and so, light glue is applied evenly between every adjacent turn. Breaking strength of the glue is 100 Newton. The spring is placed on a frictionless horizontal floor and pulled from one of its ends. It is pulled from one of its ends, so the spring should have an acceleration, obviously. So let M be mass of the spring, mass, and A be acceleration of the spring. So at any section x, here, what is the tension in the spring? So that's T. So T is equal to what is the mass, mx by L times A. So implies tension at a distance x from the free end happens to be equal to F times x by L. So that means if you look at the spring, these two ends of the spring, so that means tension in the spring varies like this linearly from 0 to F. Okay, so that means at x equal to 0, tension is 0, obviously at the free end tension is 0, and at x equal to L, tension is equal to F. So it varies in this way, okay, linearly. So now we can see that at which point tension is equal to the breaking strain. So obviously the midpoint. Obviously at the midpoint tension is equal to breaking strain. So this point, so L by 2, obviously you have so FB, that is equal to F by 2. That means we have to split the spring into two parts. One till L by 2, so till L by 2 in that part, so x equal to 0 to half L. So in that part there is no extension here, so there is no extension in this part. While now you take the other half, so in this part, so x equal to L by 2 to L, so there is extension. So we can find out the extension here. So now what you can do, that here at a certain section, so at a certain section x, okay, consider a length of the spring as dx. Now so consider this small length, of the spring. So here you can suppose that tension is same, right? So and the length is dx and the force constant is k dash. So you know that if you consider a same spring and if you cut out some part out of the same spring, then we know it very well that this k dash multiplied by the length dx is equal to k multiplied by the full length L. So that means k dash, so therefore k dash is force constant of this small part of the spring of length dx. So k dash happens to be kl by dx. So the extension in dx, I mean dx extends, right? So extension in dx is the force, that is fx by L divided by k dash, right? So that is fx by L divided by kl, and you have dx here. So that means f by kl square times x dx. So what is the total extension? The net extension in the spring, is equal to, so integration of this f divided by kl square times x dx. Now it will vary from L by 2 to L, right? So that comes out to be how much? That is f by 2kl square multiplied by L square minus L square by 4. So that means it's so f by so 3f by 8k, so that is 3f by 8k. So how much will the length of the spring become? So length of the spring will become, so length of the spring is equal to L, the actual length, natural length, plus the extension, that is 3f by 8k. So you simplify and substitute the values and find out the answer.